The Milky Way galaxy. Home to the humans. One of the trillion galaxies scattered over the universe, containing more than 200 billion stars and at least a similar number of planets. In human scale, it seems immense, right? But compared to some other galaxies out there, it's quite a small one. On Earth, distances are measured in miles. But in space, astronomers measure distances in light years. The distance light travels in 1 year is 1 light year, which is just under 6 trillion miles. Our Milky Way has a radius of around 87,000 light years. The neighboring galaxy Andromeda has a radius of around 152,000 light years, almost twice the size of the Milky Way. NGC 1399 is the largest elliptical galaxy closest to the Milky Way, much bigger than Andromeda, but even this galaxy is small compared to this galaxy. More than 1.7 million light-years across, the ESO 38376 galaxy. It is the largest galaxy ever discovered in human history, 20 times bigger than the Milky Way. If this galaxy were in the place of Andromeda, then it would appear much bigger than our Sun from Earth. But how did these galaxies form? To get the answer, we will have to go back to the time when the universe was just beginning. Theoretically, around 13.7 billion years ago, the universe began with an explosion, known as the Big Bang, an extremely hot and extremely dense phase. At that time, conditions were not suitable for galaxies to exist. Even the first stars began to form a few hundred million years after the Big Bang, and a galaxy is composed of gas, dust, and numerous stars. It takes gravity to make stars, and even more gravity to coalesce stars together into galaxies. And that didn't occur until the deaths of these early stars, which were thought to be huge, the largest possible. And the larger they are, the faster they die. Upon death, many of these stars gave birth to black holes. These black holes then use their gravitational pull to accumulate stars, gas, and dust from their surroundings, merging with one another and becoming bigger and stronger. Within these clouds of dust and gas surrounding the black holes, new stars began to form, creating primordial galaxies. Then, over the billions of years, these small galaxies collided, merged, and became the galaxies we see today or will see tomorrow. Our own Milky Way galaxy is also made up with smaller galaxies that have merged together long time ago, and some are still on their way to merging. A good example is the Sagittarius dwarf galaxy, only 6,000 light-years in diameter and located about 5,000 astronomical units away from the Milky Way. It may fully merge along with its central black hole long before the Milkomeda, or the galaxy that will form after the collision between Milky Way and Andromeda. Milkomeda will be an elliptical galaxy, which indicates elliptical galaxies form from collision between two large spiral galaxies. This is the Hoag's object, a perfect ring galaxy. Like any other galaxy, it features a bright yellow core and an outer region rich in young blue star, but a part of it completely missing and immersed in darkness, making it one of the most unique galaxies ever discovered. Ring galaxies are rare in the universe, appearing in only 1 in 10,000, and perfect ones are even rarer. Ring galaxies are thought to form through collisions between elliptical and spiral galaxies. Then there is the Large Magellanic Cloud, a satellite galaxy of the Milky Way, shows signs of being a spiral galaxy before. It is believed that as it got closer to the Milky Way, it started to deform due to the Milky Way's gravitational pull. There have been quite a few such galaxies found so far, nothing particularly interesting. But hey, early galaxies of the universe might have looked like these. Galaxies are home to stars, the stellar nurseries, where stars are born and where they also die. The stars in a galaxy are born in clouds of dust and gas called nebulas, like this one, the Orion Nebula, a star nursery deep in the Milky Way. This is the Ring Nebula, and this is the Carina Nebula, and there are many more. It's believed that at least 7 stars born in the Milky Way alone each year, and almost every galaxy follow the same process. Early galaxies were a mess, with scattered scatterings of stars, gas, and dust. In contrast, today's galaxies appear neat and well-formed. Like the Whirlpool Galaxy, the first one to be classified as a spiral galaxy, or the Black Eye Galaxy. The center is quite bright, but the outer part surrounding the center is very dark. This is the Cigar Galaxy, whose fiery stars appear to be blowing out giant billows of smoky dust. This is the Sombrero Galaxy. It has a bright nucleus, an unusually large central bulge, and a prominent dust lane in its outer disk, which from Earth is viewed almost edge-on. The dark dust lane and the bulge give it the appearance of a sombrero hat, thus the name. Astronomers initially thought the halo was small and light, indicative of a spiral galaxy, but the Spitzer Space Telescope found that the halo was significantly larger and more massive than previously thought, indicative of a giant elliptical galaxy. A really weird one, huh? From the early galaxies to today's galaxies, this transformation is largely credited to gravity, the very strong gravity exerted by supermassive black holes, which are present at the center of every large galaxies, while smaller galaxies have smaller black holes at their center. Our own Milky Way galaxy also has a supermassive black hole at its center, but because of the dense clouds of dust and gases floating in between, we cannot observe it directly. This gravitational force of the black hole pulls everything toward the center, helping to keep the galaxy together and contributing to the spiral shape over time. However, even the central black hole cannot solely maintain the galaxy's structure. Something else is also necessary. Before 1924, humans believed the Milky Way was the one and only galaxy. Astronomers used to call it the island universe. Then Edwin Hubble discovered the Andromeda Galaxy, and everything changed. Within a year, astronomers went from the universe being the Milky Way galaxy to a universe of billions of galaxies. In the following years, astronomers around the world began to discover even more galaxies. One of them was Swiss astronomer Fritz Zwicky, who, around 1933, was observing a galaxy cluster called the Coma Cluster, where more than 1,000 of galaxies are bound together by the attraction of gravity. Means these galaxies orbit around their collective center of mass. Zwicky measured the orbital speed of these galaxies and found that they were moving faster than he expected, as if there were much more matter exists than he could see, which pulling everything inwards. According to his calculations, galaxies do not produce enough gravity to stay together, and as such, they are supposed to fly apart from each other. So he came to a conclusion that it must be something that no one had detected before, and no one even thought about. He named it Dunkel Materia, currently known as dark matter. Even though Zwicky was talking about separate galaxies, later it was thought that dark matter not only keeps separate galaxies together, it also helps individual galaxies to stay in structure. To test the theory, scientists built virtual galaxies in computers with virtual stars and virtual gravity. After starting the simulation, they found it always came apart. But when they added some extra gravity following the dark matter theory, it stayed in shape. Gravity from the dark matter hold galaxy together, as a sort of protective scaffolding for galaxies. But that's not all. There exists another intriguing force that stands in stark contrast to dark matter, which actively propels everything apart, the dark energy. But this captivating subject is for another episode. Until then, stay tuned for more.